Over the next hour and a half, you'll hear from some industry leaders who have been pioneering the development of biomethane and looking to capture some of the enormous potential that it has to offer many parts of the Australian economy. My name is Mark Jonker. I'm Managing Director of Hellmann Energy. The business is a newly formed entity which is focusing its efforts on developing biomethane primarily from agricultural feedstocks. In addition, we've been actively seeking policy change to support the industry, and we're leading two working groups within the Renewable Gas Alliance, which is a subgroup of Bioenergy Australia. Those working groups include the gas injection standards and incentives and certification for biomethane. And suffice to say, it's been a pretty bumpy road, but we are starting to see some green shoots emerge. So certainly really pleased to hear Matt today talk about the Bioenergy Roadmap. So fantastic, and really great to have the opportunity to talk and facilitate this session on renewable gas. So you've probably heard that 20% of Australia's total energy consumption has the potential to be derived from bioenergy. That's quite significant. It means that bioenergy can do the heavy lifting in hard-to-abate sectors such as transport, aviation and heating. Now, the key to all of this is creating commercial scale facilities that reduce costs and see bioenergy compete with conventional fossil-derived energy sources. What's really exciting is that we're starting to look across to other jurisdictions and see the benefits of biomethane. And sometimes that's referred to as RNG, or renewable natural gas, as a way to displace natural gas. Now, by using biomethane instead of natural gas, we're able to ensure carbon that was deposited underground millions of years ago remains deposited underground into the foreseeable future. And that's one of the ways that biomethane reduces carbon emissions. Other ways include avoiding fugitive emissions from the decomposition of organic waste. We're starting to see soil carbon emerge as an opportunity to reduce further emissions from biomethane, and certainly the benefits of using biomethane to firm up intermittent renewables can establish and create, I guess, new renewable energy projects where, you know, additional wind and solar can be installed and be complemented with biomethane fueled generation, which is on call. So today we've got three industry leaders here to present to us on biomethane. Before I introduce the speakers, I'll quickly address the basics of biomethane. So firstly, biomethane is chemically the same as natural gas for all intensive purposes. So that means it's somewhere between 96 and 99% methane. It does contain a small amount of inert gases such as nitrogen and some trace elements of CO2. But biomethane is essentially biogas that's been upgraded So biogas, in contrast, contains approximately equal amounts of carbon dioxide and methane. So 50% methane, 50% carbon dioxide. What we've seen over the last 5 years is a maturing of the technology to upgrade biogas into biomethane. And today we've got a number of different vendors who offer a range of technologies to upgrade biogas. So these technologies include water wash, amine systems, membranes, and pressure swing absorption, generally coupled with anaerobic digestion or landfill gas, or other biogas that might be produced from facilities such as, you know, covered air, covered anaerobic lagoons, or wastewater treatment plants. So these vendors are largely based overseas, but are increasingly offering services to the Australian market. So we're certainly excited to see the release of the Bioenergy Roadmap, and we'll hear Josh Moran talk shortly about the biomethane technology and how it's poised for exponential growth. So to put things into contrast, in Australia, we've got one biomethane project. Across Europe, the US and Canada, there are over 1,000 projects. So in 2020, for example, the US produced 56 petajoules per annum of biomethane from 156 projects. So that's about 75% of the industrial gas consumption within New South Wales and the ACT. So that's quite a significant amount of renewable gas that's been injected into the gas grid in the US. So this hasn't happened by accident, all driven by policy that has supported market development. And primarily that market included a market to decarbonise the natural gas grid, but also, and interestingly, a market to decarbonise the transport sector. So biomethane in some jurisdictions is being injected into the gas grid, upgraded into CNG and used as a diesel displacement fuel. So those sorts of policies have seen biomethane projects developed in those jurisdictions. It is fair to say that in the US, the policies vary across each state, but what there is there's a common federal policy called the Renewable Fuel Standard, which has harmonised project developments and effectively provided access to biomethane to any user across the country who has the ability to draw natural gas from a natural gas grid. So whilst we've had some great progress with the Bioenergy Roadmap, we've got a lot more work to do here in Australia. The unfortunate reality is that we don't have a policy mechanism at the state or federal level that can actively promote the wave of investment that could be available in the biomethane sector. So a couple examples. Biomethane users, so people who are looking to green up their Scope 1 emissions by using biomethane. At the moment, they can't access green gas and the benefits of green gas from the grid. So that means if they were to buy it, which they can do, they're not able to access the environmental benefit by using it. So ultimately, that leaves the end user having to report on their emissions under our reporting framework on the basis that they've bought natural gas. So that presents a barrier. We've heard today about some issues around digestate. That's a common issue for anaerobic digestion projects. There are a number of different interpretations for how waste is treated and how digestate is treated across the states, and that adds complexity and risk and cost to projects. And whilst we've seen, and we're certainly excited to see the development of a new biomethane ERF method, it doesn't really touch the sides when it comes to the total resource that's available out there. And we saw Matt this morning talk about 2,600 petajoules of bioenergy resources are available. So the ERF method really focuses on a very small subset of those resources. But the good news is that ag waste will find its way into the method over time, and that represents around 40% of the bioenergy resources. And the method will hopefully be extended to support other resources. So in this session, we're going to hear from pioneers from this emerging industry. Josh Moran, Commercial Manager at Jemena, will be talking about the Malabar biomethane project, as well as some of the opportunities to decarbonise the gas grid from bioenergy resources around the Griffith area. Josh has been leading the charge. He's chair of the RGA, and I'm certainly very privileged to have the opportunity to work alongside Josh and support the RGA with the gas injection and incentives working groups. Joe Oliver, from Managing Director of Delorean, will talk to us today about some really exciting developments currently underway within his company. So the team at Delorean have been quite achievers, and over the last 8 years, Joe and his team have been trailblazing the industry. They've developed, I guess, two of the three fixed tank anaerobic digestion projects across the country, and I'm certainly looking forward to hearing more about Joe's projects and source separated organics and the potential that can bring the industry. And we also have Aidan Mullan talking to us from the perspective of a gas consumer. So as you can appreciate, none of this happens without customers. So this industry needs customers to purchase the product. And it is true that the federal government will leave heavily on the ESG movement and the voluntary market to reach net zero. So we need people like Aidan to buy the product. So Aidan works for Interface Australia. It's a 50-year-old Australian manufacturer that produces carpets and tilings for the building industry. The company is leading the way, and they're doing the heavy lifting to decarbonise industrial emissions. So certainly no doubt that companies like Interface Australia are critical to our industry and supporting increasing supply and cost efficiencies in biomethane. So to that end, I'll hand over to Josh to kick us off. And at the end of the session, we'll have a short session for some Q&A. So if you can just log your Q&A in the panel, that'd be great. Thank you very much.
Thanks, Mark, and thanks for your leadership in the bioenergy space, and thanks everyone for today, especially Bioenergy Australia. So what I'm going to take you through today is the decarbonisation opportunity and challenge. So the gas network in New South Wales takes about 80 petajoules of biomethane, sorry, of natural gas at the moment. And there's obviously quite a challenge in getting the gas required to decarbonise that. So what I'll take you through today is taking you through the different feedstocks that we might be looking at to actually decarbonise that gas supply, building it up from different opportunities, and then taking you through how we're utilising some of the early gas through our Malabar biomethane project, and then how we're trying to expand that, because it'll become quite clear that we need everything to meet this challenge. And then what I might be asking from you as well is in developing this industry, we'll need to really understand how to utilise some of the agricultural resources. And that's something that we need to build on knowledge, build on experience, and just be putting forward some ideas, and it'd be great to hear your feedback on them. So first of all, as I noted, we can get some low-hanging fruit. We've got some opportunities to decarbonise the gas supply in the short term from landfill and waste. So this is a graph of what we might be able to capture from those potential sources. So that'd be flared gas. So that is easier because it's waste gas that just needs processing. It's there, it's available. We just need to compete with flaring and electricity production to get it. Then you've got the sources that are collected already, but they're not currently converted into gas. So they need processing, and they are wastewater, which obviously sometimes is converted into gas, but organics is mostly not converted into gas currently. So we need to justify the conversion of that material or the diversion of it to renewable gas supply. And these are the couple of aspects and couple of supply points for biomethane that we're focusing on at the moment in the short term. But we're very conscious that we need more, as you can see by the gap between what we have there and what we need. So this is just a quick diagram of actually how some of these projects might work. So this is just on the revenue side, because it does vary how you can get these projects over the line based on what the revenue and costs are. So first of all, with these types of materials, you could be paid to receive them, which really does help the model. So you just need to compete with landfill and composting. At the moment, you've got you will hopefully soon have an opportunity for carbon reduction incentives, and then also you can sell that gas currently, but there's low recognition of the value at the moment for that renewable gas, and that's where we're coming in with certification. I mean, the benefit with these types of projects is that you've got a reasonably constant feedstock. They are sort of smaller scale, so there are some higher capital cost contributions, but especially for waste gas, you only need to upgrade it. So that really reduces the capital requirements. At the moment, there's probably higher risk because there's no other biomethane projects in Australia. So we're working on that, and also there's sort of reasonable injection costs. So at the moment, without the ARENA support, there would be a challenge with getting the initial projects over the line. So that's why what we're doing is we need to drive the industry. So we recognise that this is a market. Us as Jemena, we are an energy infrastructure company, and what we do is we deliver energy to our customers and operate our networks on behalf of customers. So we own most of the gas network in New South Wales. So we know that in order for our customers to access renewable gas to decarbonise, like interface carpets, we need to have a supply. So by developing that market, we can actually enable them to decarbonise. And the key part to that is certification. That's something that we're working on so that you can actually get the value from the gas that you inject. So you don't just get a wholesale gas price, you get a premium similar to LGCs or green power electricity certificates. What we also need to do is reduce that cost to produce. So that's on risk. So we are needing to understand those risks, make sure that we get all the processes right so you can inject. And then we also need to demonstrate and support these, because it is really key for us to get this renewable gas into the market. So it makes sense for us to be the first mover. And where we are the first mover is on our Malabar biomethane demonstration project. So this is a project where we're taking biogas that's currently flared at the Malabar wastewater treatment facility and upgrading that to renewable gas. And that'll be about 100 terajoules per annum up to 200. And that is equivalent to about 7,000 homes. And to give you a bit of a scale perspective as well, that's producing more dispatchable power than the Hornsdale battery every 3 days. So it's not just for homes, it's for dispatchable electricity, transport, etc. And we're looking to be injecting this gas into the network in Q3 2022, and it's progressing along well. This is a 3D model of the facility, so where the upgrader will be supplied by Enerarc, and they're actually excitingly going to be putting that together in Australia. So another way that we can be developing the supply chain to drive down costs for future projects. And we're going to have a biogas storage, which will enable us to balance and improve the efficiency of our upgrading. So all these learnings from this project that is supported by ARENA, which is great, and we really appreciate it. These learnings will be transferred so that everyone can benefit and drive down the costs of renewable gas. So what we're looking to do, as I noted, is that we want to be able to increase the carbon incentives, which is coming through the Emissions Reduction Fund, biomethane method. We're bringing in certification so we can improve the sale price of gas. We're looking at we're trying to reduce the injection costs and processing costs. So we're understanding how they're operating, bringing in innovations like the biogas storage buffer. We're also trying to develop supply chain to bring down that cost, and then trying to understand the risks, and so that a new developer can come in. They know how they get injected in the network, how they interact with AMO, how they sell the gas, and there's a market developed. So that reducing the risks so that we can get to a point that the projects are viable. So covering that perspective of our pathway to decarbonisation, what you're here for is around regional and agricultural waste. So this is where we see a reasonable percentage of this coming from, a reasonable percentage of our renewable gas coming from this. At the moment, we've got some conservative assumptions in this of the percentage captured, but that will change as we learn more and try to bring in more renewable gas. So this is a bit different, as you well know. With the other projects, all we need to do is we've got feedstock that's available basically at our gate, and we need to be able to process it. Obviously, there's a lot of challenges with that, but this is an additional challenge with agricultural projects. One option you've got is to sell digestate. That is an additional revenue stream for that, in addition to the other revenue that is available. There are more challenges, obviously, with the variation in feedstock, which creates challenges for utilisation of the plant, as well as some risk that comes into that because of the variability over time. You've also got to actually get that feedstock to site with a lot of agricultural materials, especially when we're talking about getting all the gas that we need out of these materials. So you need to purchase it, and you also need to deliver it to the facility. And I suppose there are also challenges with where the projects will be, because the other projects are urban. So that means that you've got a gas network nearby, it's at lower pressure, whereas the other projects, they need to be at scale, but they might just be near transmission, which creates additional costs, which means that you might not be able to get to the viability of these projects. So we need to work on this. And the way that I sort of split it up, and this is where it starts to be a question for people on the call, it'd be great to hear your thoughts on this, is that we need to be able to sell the gas. So we'll process the material, produce the gas, inject it, and sell it for a margin that can pay for some of the feedstock, which then means that I can reasonably understand what the margin might look like in terms of when we go to scale on agricultural projects. But what we need to then understand is how does that interact with the potential feedstock costs. So what I do initially is just to understand what the potential margin would be on that energy. So if we got the feedstock free, basically at the facility, what margin could we get from the production of that gas that could potentially support bringing that feedstock to the site? Because this margin defines what you can pay for the purchase, collection, transport of that feedstock. And then if you can sell the digestate, obviously that's a benefit as well. So all the stuff I talked about before in terms of certification, etc., I'm trying to push that margin up so that it can support more value for the feedstock coming in. So what we need in the end is an energy margin that can actually support a material cost, net cost at the gate per gigajoule. So the way that it's been approached overseas has been, where it's been successful, has been that you can do tariffs or targets that actually push up the energy margin, and that sort of solves the material cost problem, because then that pulls that gas through. But unfortunately, we don't have that. Even though we'd like it, it would be great. But what we need to be able to do to ensure the viability of regional projects is to make that energy margin more than the cost of moving that material. And the way that I think in sort of energy terms, when you've got that material, that's a potential energy that you need to be able to supply to site. And so the cost of getting that energy to site is dependent on transport cost and the energy density. So when you work through it, if you've got an energy density of that material of 4 to 9 gigajoules per tonne, which was based on some QT numbers that I saw, you would probably need to have a net feedstock cost between $20 and $60 a tonne. And the reason why I say net is that if you are not doing anything with the digestate, then actually you need to your maximum would be $60 a tonne. But if you can sell some of the digestate, then you can actually net that out, and that would be your sort of level of cost of feedstock that would be in sort of the reasonable range. So that was a sort of initial ideas around actually how we can drive the feasibility of regional bioenergy projects. It'd be great to get your insights on what that sort of looks like. So what we did is supported by a Future Fuels CRC project, which was completed by the University of Adelaide, where they looked in this in a little bit more detail. So they used Griffith as a case study, where they looked at used quite a complicated model, optimization model, that looked at all the different inputs, the potential restrictions in the output, and then did an estimate of the capex and opex of that plant, and they came through with some results, which was actually quite interesting. So this it demonstrates that is potentially viable, but obviously it depends on some key aspects. So first of all, co-digestion is actually quite important, because if you have a single feedstock, then that obviously creates challenges for the utilization of the plant, as well as you can get more energy out than the individual pieces. That's based on some anaerobic digestion work. The obviously material movement and value of that waste, or the opportunity cost of that waste, is also very important, as I noted before. And Griffith does seem like a good opportunity. The next step of that project, and an opportunity for anyone to get involved, is that there's actually going to be a model produced based on this work that will be accessible to people to be able to model their projects and see, actually, all right, if I did this, if I had this feedstock, how will that work? What is the optimization of this to see how I can make this project successful, which is great. So there'll be hopefully some announcements, but it's being worked on at the moment, and I don't have a time frame on that as it stands. I believe it's sometime next year. So based on this and the understanding of these regional renewable gas projects, obviously we need to do more as an industry. So the scale of projects is important. So what we've got to do is advocate for scale development, and then feedstock collection and risk support, because the transport is important. And also managing the variability of that feedstock and who takes that risk of the feedstock supply is very important. We also need to enable those other value streams, because that can mean that net cost of that feedstock to site can be reduced. And then supporting the industry and transfer knowledge from our other developments. So that's being Future Fuels and the Malabar project, so that we can drive up that potential energy margin that can support these regional projects. So where can this go to? If we get improved ability to sell digestate, we've got we've got carbon reduction incentives that hopefully will come through in the emissions reduction fund. We can sell the gas at a higher value, which we're trying to do through our other components. We can purchase material and delivery, getting it to site at a lower cost. And then diversifying the feedstock and utilising a variety, even energy crops to balance it. We need to that can get high utilisation. That's very important. And then risk of those feedstocks and how that's shared is still a challenge, and we really need some support for that. But hopefully, if that all comes together, we can get a project that works. Where we see this being enabled, because scale is very important and diversity of feedstocks is very important, is through bioenergy hubs, or if we're really ambitious, bioenergy zones, similar to the renewable electricity zones, particularly in some really good production areas. And these are some of the places that have been noted. The other spots on the map are potential biomethane projects, and that'll really work well. Building on sort of smaller projects and then building up into these hubs is something that's very important. So now we've got this, hopefully we're going to be able to deliver these materials that need collecting. That gives us a bit more of a feedstock for decarbonising our grid. And as they say, we do bioenergy to the moon if we can actually get that 250 PJs that was noted in the Bioenergy Roadmap in New South Wales. But we've also got parts of our strategy that does include hydrogen, but obviously it'll balance dependent on what's viable, and that final decarbonised future that we're striving for will really depend on how we can drive some of this viability and how we can support this burgeoning industry. Thanks.
Great, thank you, Josh. I love seeing that chart, showing the different contributions from the various feedstocks and biomethane and hydrogen, and the key standout for me is just how much heavy lifting biomethane does before we start to see hydrogen really take a leading role in decarbonising the network. So yeah, really good to see that, and certainly carries forward from what we see in other markets as well.
Yeah, thanks.
So next up, we've got Joe Oliver, Managing Director of Delorean, and I'll hand over to Joe, and he can tell us all about his projects. And he's been at it for 8 years, so certainly looking forward to hearing about some of the challenges and some of the wins that have come his way over the last 8 years. So over to you, Joe.
Just checking that you can see my screen. Is that right?
I can't see your screen. I've got. I can see. I think I can see the Bioenergy screen.
So you can't see my slide deck, no?
No, I can't.
Let me just stop sharing and try again.
That's great. I can see that, Joe.
So if does that work now?
Yep.
Perfect. Apologies for that. So first off, just to introduce myself, I'm Joseph Oliver. I'm the Managing Director for Delorean Corporation. Just before we get going, I just first off, I'd just like to say it's been with great sadness that we heard about the Fiona Waterhouse passing. I think we need to acknowledge and recognise the work as one of the early pioneers in the bioenergy space and the work that she did. And it's an incredible loss to the industry, and we wish her colleagues and family all the best. I'm going to talk about what we're doing in Delorean Corporation, and I've got about 20 slides that I'm going to go through, and just mainly around the work that we're doing here in Australia and across in New Zealand. So Delorean Corporation, we're a listed entity. We actually listed in April this year. And we're listed around the focus of bioenergy. We're actually one of the only stocks on the ASX that is bioenergy focused. And our driver is around delivering a nationwide approach to the capture of organics, the renewable generation market, the generation of green gas, and offsetting and diverting waste from landfill effectively. Across our organisation, we're split into 3 divisions. So we've got an engineering division, an infrastructure division, and an energy retail division. Formerly, Biogas Renewables was our engineering division that you might be familiar with, which we built out the Jonker facility, which is seen as one of the success stories, the commercial success stories here in Australia. And mainly that's focused around the commercial industrial food waste, processing that material and inputting energy into the grid to decarbonise and electrify. So a real focus across our business is around engineering from a construction of bioenergy facilities for third parties that we'll talk about shortly. The infrastructure division is focused on the development of projects, and the energy retail side is really focused on capturing the green energy that we generate and wholesaling and retailing that to the industry. So I think we're all familiar with what bioenergy is. It's the breakdown of volatile matter for energy production, and we know that there's different forms of energy production. So I'm not going to talk about it too much, but these first few slides just highlight what our in-house capability is working on and is delivering. So we're focused on that domestic commercial organic waste stream. outputting a fertilizer as a digestate, replenishing the nutrients back to land, and equally generating renewable energy. We're really focused in the green gas space, and that's mainly because fossil gas, there isn't a lot that can replace fossil gas in terms of from a renewable natural gas. Mark talked earlier about renewable natural gas being the same as natural gas. Hydrogen obviously is a different form, needs upgrade, how it's managed through the network and others. Whereas renewable natural gas, this is what we see in Europe, a real driver around renewable natural gas, and predominantly from bioenergy as one of the only forms that can process that. Compared to solar and wind and other electrification networks that we're able to see there. So Delorean's focused on the development of multiple facilities nationwide, and we've built the Jendicott facility. We're in the final stages of commissioning. We've commissioned a facility for Blue Lake Milling in South Australia that's processing oat husk, which is it's the first in the world. Exporting power now. We're building facilities in New Zealand, East Coast, and we've got quite a few in development in addition to that. So we're really trying to drive this market forward with everybody, basically. I think we see there's a great market for that. I'm just touching on the engineering side, which is our third-party projects. So the picture that you can see in front of you is the oat husk facility for Blue Lake Milling in South Australia. And that's energy behind the meter utilizing oat husk. It's the first in the world. And it's generating up to 1 meg of energy that would be consumed behind the meter with some spill into the grid. In addition to another facility across in New Zealand, which we're in construction with, processing food waste from Auckland City Council. So we've been working on these projects for the last few years. It's certainly been a difficult, challenging time during COVID, but we're pushing our way through with localized and driving those projects through. We've also announced recently is the preferred tender status for the Yarra Valley Water project in Victoria, that we'll be moving that into contract and into build in the new year. So we're really starting to see some traction at this moment in time within the renewable energy sector. And I think what's important is how do these facilities make money? If we want to make a success of bioenergy, we need to understand where the revenue streams are. I think Josh touched on a few of them around the biomethane side, but where our focus is around diverting waste, organic waste from landfill, and processing through digestion to get a higher value, a higher return by capturing the nutrients, outputting as digestate, and equally offsetting fossil gas with renewable gas or electricity and heat, and decarbonising the networks as we're committed to do. In terms of Delorean, where we're heading is to continue the growth around our own projects. I think we've been equally frustrated with the market around the delivery of renewable bioenergy projects nationally, and we've been really working in that space to develop the projects, which take quite a bit of seed capital to get it to the point that it's shovel ready and investable, basically. And that's something that we've been working on. One of the projects that I'm going to touch on is the South Australia 1 project in Edinburgh Parks, where we're pushing that through to FID. And we've been working with AGIG on this project, which is to upgrade biogas from the facility into natural gas and input into the grid to offset the unaccounted for gas that's there. The facility, we'll talk about the technology and I guess the rationale. We struck an MOU with AGIG, Australian Gas Infrastructure Group, are the largest gas network operator here in Australia with networks in most states. And we've been working with them for quite some time now around how do we manage, assess, input green gas into the grid and make a success of it. So we're working through the final stages of that project. We're technology agnostic when it comes to deciding which technology to go with for biogas to biomethane upgrade. And I think Josh talked about a couple of the processes. We looked at the advantages and disadvantages against our project, the volume, the input requirements, meeting the Australian standards, and what was required from a calorific value and others. So our selection was to go down the water wash process, which I'll talk about in more detail. Rather than list the pros and cons, there's a lot of technology is moving quite quickly in this space, and we see some really good advantages of being able to align to what's required to meet the natural gas network. So when we look at wash water, effectively we're carbonizing the water and flashing it off, basically. So similar to a soda stream, we're putting it through at high pressure, flashing out the CO2, and we're getting a relatively pure biomethane out of that at 98%. So we're able to comply to the AS 4564, which is the injection of natural gas into the mains. And we're working through a calorific value of that 3.26 megajoules per cubic meter. So when we look at input of green gas into the grid, there's probably three major areas once you comply to the AS 4564. One is the heating value, the second is the temperature, and the third is the pressure, basically. So we've done a lot of work in that space. We're connecting into the low pressure mains, and we're able to input around 150 to 200 TJs with AGIG through this facility that we're in build with. The facility, sorry, just before I move on, the facility that we're in build with is processing commercial industrial organic waste from the market for energy production. So I guess unlike Josh's project, we're not taking gas from the wastewater treatment. We're actually processing that and generating that gas on site. In terms of green gas, we feel like it's slightly forgotten with the current times from a hydrogen perspective, and we see a lot of drives around hydrogen, which we understand. When we look across Europe, the main focus is around green gas from anaerobic digestion and bioenergy, and that's really about driving the offset of fossil gas with renewable natural gas. And you can see the infiltration across Europe as more facilities are inputted. And recently we were talking to Denmark around their drivers, which is 100% green gas from AD. So a lot of key drivers. This is mature technology that's been done all over the world, and it's achievable now. One of the main elements is that green gas is commercially viable. I think Josh had between $0 and $7 a gigajoule. I think we're seeing more like the $8 to $14 a gigajoule, which is slightly more than fossil gas, but compared to hydrogen, quite a bit less. So we're seeing hydrogen at $5 a kilo and just short of 8 kilos per gigajoule, requiring about $40 a gigajoule to be as a comparison. Now, if hydrogen can get to less than $2, then we're still at that $16 a gigajoule mark. So green gas is commercially viable now. There is offtakes. We're seeing everything from CNG in buses in most states to behind the meter gas consumers, which I think we'll talk about in the next slide, such as Brickworks. So Brickworks' requirement was they wanted to continue increasing their emissions offset and reduction around generating green bricks, basically. And they've explored the hydrogen market and other forms of gas. They're one of the largest gas consumers nationally, and their driver is to offset that gas on site with green gas behind the meter to enable that emissions reduction. So we've been working very closely with Brickworks. We've got an MOU, and we're looking at a rollout nationally, creating a on-site processing of waste for gas production that will offset their fossil gas that's currently being used. So a great milestone in this space. And I think what you can see is that with the electrification of solar, wind, and others, then it creates the opportunity of green gas that needs to be viable, but equally offset against fossil gas to really drive that forward. So nationally, we know that there's over 12.5 million tonnes of organic waste, excluding the agricultural and fishery waste. So when you factor the agricultural and fishery waste, you're up at nearly 50 million tonnes of organic waste. Now, with that waste stream, that's prime use through bioenergy in this form for gas production. Gives a great opportunity when you can see the likes of 3 million tonnes in Victoria, New South Wales, and Queensland that can be captured for energy production rather than inputted into landfill or composted or other forms of waste management, where we can extract value, a higher value, by inputting through a process to offset fossil gas with green gas. So a real circular economy that we're starting to see, and that's really, really good. Within Delorean Corporation, we've actually got around 500 mil of proposed projects that are in early stage engagement, feasibility, development, construction, commissioning, and operation. And we're seeing that there is federal and state support that we'll talk about shortly. But when we look at that, across that portfolio, we're seeing around 3.1 million gigajoules of energy being able to be created through that pipeline of projects that we've got, which is a diversion of about 1.5 million tonnes of organic waste and offsetting 1.6 million tonnes of CO2 abatement. So a real driver around emissions, waste diversion, and generation of green energy, and in the form of renewable natural gas. So we are seeing state and federal support from the likes of ARENA through to Queensland, Victoria, New South Wales, all around bioenergy, supporting that bioenergy at a local and a state level to really drive for a greener future. Inclusion of the support from the Clean Energy Finance Corporation, really driving that sector to support where green gas should be implemented. Again, obviously, I won't touch on this too much because I appreciate that it's probably been covered quite a bit. But the Bioenergy Roadmap has really helped to highlight where we need to be. We'd always like to have seen a bit more cash in the kitty, but at the same time, I think we recognise that it's great to get bioenergy on a roadmap. It's mature technology, and we want to see that being delivered. So that wraps up my presentation. I think I've probably got it about right from a timing. Happy to take questions at the end, and I'm going to pass across to Aidan Mullan.
Thanks.
Aidan, I think you're on mute. Sorry, I think you're still on mute. Hello.
Aidan, apologies, still can't hear you, even though mute appears to be turned off.
How's that?
There we go.
Perfect.
Excellent.
Okay. Right, can you actually see my screen? Yep.
Yes, we can.
Okay.
We'll make it full screen and we're good to go.
Okay, we'll do that now. On my full screen. No. This worked perfectly the last time we did this.
It's always the way, Aidan.
Yeah, it worked perfectly. Okay, here we go. Let's see.
No,
How's
no
that?
pressure.
You got that? Can you see that?
Yeah, I can see that. That's
Perfect.
great.
Oh, good.
Thank you.
Oh, sorry, guys. Yeah, who said about the good wine left to the last? And if you've got a bottle close, have a glass now, and I'll kick off. Look, actually, just as Joe said earlier, I'd like to dedicate this presentation to the memory of Fiona Waterhouse, also CEO of Utilitas. Fiona worked very, very closely with Interface over the years to try and actually source an alternative supply to natural gas. So in this presentation, I'm just going to give you the end user's perspective. I'm going to take you through who Interface are, what we do, and why we've been determined to find renewable energy alternatives for a manufacturing facility here in Minto for the last 6 years odd, you know. So first of all, we are a worldwide leader in design, production, and sales of commercial flooring. That includes modular carpet, you know, luxury vinyl tile, and rubber tiles and sheet products. And really what I would say is that our business is underpinned by purpose, and we're committed to minimizing our impact on the environment while at the same time enhancing our shareholder value. And this commitment to that purpose is exemplified by our Mission Zero initiative, which is all about doing no harm to the environment. And we're actually going to take that further now with a new initiative called Climate Take Back, through which we become restorative. So in doing the damage we've done, and in doing so, we want to lead the industry in designing and making products that, you know, will maintain a climate fit for life. And to give you a bit of perspective, you know, we're the world's largest carpet tile manufacturer with sales in over 110 companies, 6 manufacturing locations on 4 continents, including our facility at Minto, Southwest Sydney here, listed on NASDAQ. We're about $1.5 billion company, 4,000 employees worldwide, sustainability leader, and we've been manufacturing in Australia, as Mark said earlier, there for over 50 years this year. As a sustainability leader, you know, there's a GlobeScan survey that runs annually, which surveys 700 of our peers in the industries. And Interface has always been ranked in the top 20 for the last 25 years. Not only that, for the last 10 years, we've been actually ranked in the top 5. And 2020, last year, we got a Climate Action Award for this Climate Take Back initiative and some of the new products that we're putting onto the market. So it sort of gives you a perspective of our sustainability chops, as it were, all due to this guy, our CEO and founder, Ray Anderson, who in 1994 had that spear in the chest epiphany where he wanted to take our manufacturing business from a take, make, waste model to a cyclical model like nature, where, you know, reduction in embodied carbon and circular economy are key. And basically that's where the Mission Zero plan came from, to set the target by 2020 so that, you know, we could show the entire industrial world, you know, people, process, product, place, and profits, that we can be sustainable. And in doing so, be restorative through the power of influence. And, you know, we always talk about Mount Sustainability and zero impact at the top. And back in '94, when Ray had that epiphany, we actually developed a roadmap to help us achieve that. So there's basically 7 fronts here, you know, eliminating waste, denying emissions, but 2 of the key ones here, renewable energy and closing the loop. So that's reduction of embodied carbon again, and circular economy. And they go hand in hand for us to achieve basically our zero impact on the environment, and then going forward to become carbon negative. And for the purposes of this presentation, I'm just focusing on the renewable energy element. And our goal is that all our manufacturing facilities globally would be on 100% renewable energy. Aim being that we would actually cut our link to non-renewable resources and start to take products that already exist and use renewable energy to manufacture new products. So that's the ethos of the company. Back in '94, we started measuring our performance against our goals and targets. And this here would actually summarize the 2020 ecometrics. And the ecometrics is our measurement system, which is designed to sort of quantify the metabolism of our operations. So in other words, it details how much we take in terms of raw materials and energy, how much we make in terms of product, and how much we waste, materials and emissions. And you can see there, really, we had a pretty good achievement with a 96% reduction in greenhouse gas emissions. We've reduced the carbon footprint of our carpet products by over 76%. And you can see that link between renewable energy and then diverting waste from landfill and getting into the circular economy. We've actually increased the material content up to 60% recycled content and bio-based sources. 90% of the energy we use in our facilities is 100% renewable. And that includes in the US and in the Netherlands, we use 100% green electricity and also green gas. Here in Australia, we have a ways to go to get the green gas alternative. So 2018, we became the first company to produce all carbon neutral products across the full life cycle of those products. And of course, that is achieved with offsetting. But our aim is not just to achieve net zero, our aim is to achieve zero impact. And this year, we actually produced our first carbon negative carpet tiles. And over the last 20 odd years, you can see, initially our carbon footprint was around about 20 kilos CO2 emissions per meter squared. Last year, we were down to an average of just below 8. And of course, when we released the new carbon negative carpet tile to the market, that's a minus 0.3 carbon emissions cradle to gate. And that's a result of using high recycled content, a less is more approach, renewable energy, and also a lot of bio-based materials within the product. So ultimately, our goal is to become carbon negative by 2040. And we recently just signed up to the Science Based Target Initiative with a 50% emissions reduction commitment on scope 1, 2, and 3 by 2030. And then, of course, beyond that, our aim is to become carbon negative by developing new process technologies, innovative materials, and coupling that with a very efficient circular economy model. The facility here in Minto, well, it's actually quite a new facility because our original facility in Picton was destroyed by a catastrophic fire back in 2012. And we commissioned a new facility within 18 months of that disaster and got it up and running at Minto. And the factory at Minto basically is 24,000 square meters under roof, some stats here. We manufacture up to 15,000 square meters of carpet a day. That's the capacity. And an energy mix that we use, 35% electricity, 65% natural gas. We're operating on 100% renewable electricity since 2011. We've been sourcing an alternative to natural gas since 2016. And our current use is around 12 terajoules per annum. Now we're going to increase to about 15 next year because we're expanding the facility in Minto. And there's a couple of areas where we use the gas, particularly at the end of the process. We have what we call a Precoat Line, and we also have a backing line. And I'm just going to play a couple of short videos and talk over them, and you can get a feel for really what carbon manufacturing is about, the size of the equipment we use, and why we've looked at the alternatives, and why we've come to the conclusion that we really need a biomethane source. So, the Precoat Line here uses about 60% of the gas in the facility. And hopefully this video will play okay. If it's a bit clunky, I'll just move on. But you can see here that it's a continuous process. We just join the sheets of carpet that we actually tuft every day together in order form, and then we process that through the Precoat Line. Now this line, basically what we're doing here is applying a water-based EVA latex formula to the back of the carpet, and that actually seals in the tuft that's on the carpet. And then when it comes out of that part of the process, it goes into a large oven operating around 200, 250 degrees centigrade. And you can see the gas burners along the side there, coming out the other side. The tuft lock is sealed into the carpet and it is ready for the next stage of the process. And then we take that further to our backing line. And this is really where we actually apply a well-engineered, reinforced vinyl composite backing, mostly limestone actually, with some vinyl resin, plasticizer oil, and glass fiber sheeting. And again, the carpet runs continuously through here on a 1 or 2 shift basis, depending on requirements. We actually apply the glass fiber at this part of the process. You can see it down the left-hand corner there. And then the actual backing itself is actually added in paste form. So it's a very viscous liquid. You can see it here, stage 1, stage 2, introducing the glass fiber. Then we apply more of the plastisol, we bring down the carpet, and we run that over a heated surface which uses hot oil. And that hot oil is heated by gas. So the process heating supplied by natural gas, again, up to 200 degrees centigrade. Peels off, and then it goes through an accumulator. We get a cooling process here, and then we take the carpet on to the very last stage of the process, which effectively is a large cookie cutter. And that actually cuts the carpet sheet into tile, either in square form or plank form. And then it goes through quality inspection, gets packaged, and of course we ship out to our suppliers. So you can see the scale of the equipment here, not easy to replace. When we rebuilt this factory post-fire, we didn't have much choice. We couldn't add much in the way of bells and whistles, and we went for the standard technology, a like-for-like replacement, because we had to get back up and running again. So therefore, when we started looking at alternatives for natural gas, not an easy thing to do to convert this type of equipment. As I said, we've been here for 50 years, expanding next year, and of course our goal here really is to be on 100% renewable energy at this facility in Minto, and we hope to do that next year. So looking at the alternatives, as I said, we've been on this journey for a long time, but certainly in the last 6 years, some of the things we looked at, electrification was a no-brainer. We could use microwave technology and actually use less electricity to cure those products on the backing and Precoat lines. But again, the equipment required further development, and there would be quite a high capital cost to that. Secondly, we looked at solar thermal type process heating. Again, very effective. It looked like it was applicable. We did a case study and we did basically a good project review on all the solar thermal equipment out there at the time. But we did come up to the conclusion that, again, because we have the ability to run around the clock, we would have an issue with off daylight time running, and therefore we'd require very large storage or buffer storage of hot thermal oils on the facility. So, and again, high capital cost. On-site biodigester seemed like a great idea until I started to talk with Fiona Waterhouse and realised just how big a footprint these things can have. We would have said goodbye to the car park, so we just moved quickly on from that. We looked at virtual pipeline, and again, initially we were talking with Phil and the guys at Sydney Water to see could we get biogas and get it compressed and get it carted down to the factory and run it from there. Again, a lot of high traffic, on-site storage were issues, and there were big negatives with our requirements. And then really we started to look at biomethane and direct displacement. And initially we had this concept that, again, looking at the circular economy, we take back our product end of life. And we were thinking of a precinct somewhere near a waste facility, near the pipeline, where we could actually generate the gas, run the recycling facility, and the surplus gas could then be injected into the mains that we could use for our factory. That was a great concept, and we looked around that. And this was the time when I first met Fiona Waterhouse, and we actually developed a strategic plan to try and access a biomethane source. And this little diagram here gives you some idea. This is Fiona's scribbling back in 2017. And there's key things in there. We really decided we'd actually focus on the middle here. Look at who all the stakeholders are across that supply chain. And number 4 there, identify a friendly network owner, was very important. And that was where we tried to actually start making contact with the network operators, the transport management companies that actually carry the gas around the country. So, you know, from there, we had a lot of meetings, a lot of discussions, and we certainly kissed a lot of frogs on the way to trying to achieve a biomethane source. And really what we wanted to do really was, you know, find out if we could actually get someone who would assess the viability of taking refined biogas into their network, hence the friendly network operator. I'm going to raise the flag here and says Jemena. And then provide clear direction how, with respect to how acceptable the gas quality would have to be, you know, and look at overcoming the obstacles to future partnerships, processes, infrastructure requirements. All those things were on the table, and we had lots of discussions around that over the years after that, from 2017 onwards. And really, at the end of the day, what we wanted to try and get in on was partnering at the pilot scale stage, which would allow sort of a no surprise process where issues, concerns, and opportunities could be addressed. And I think that's what we've actually done, because effectively now where we're sitting, we're really looking at next year having access to biomethane from the Malabar project. And Josh referred to that initially there. Beautiful example of circular economy. I've been down on the facility myself. Shame to see all that good gas being flared off when it could be purified, pressed, and injected into the line for our use. And that's exactly what we want to do. So our goal next year is really to be online, to be one of the first customers for that. And we hopefully that will come to fruition in Q3, as Josh mentioned earlier. I think, you know, I'm not going to hang on too long, because as an end user, we haven't been sort of floating out there on the sea waiting for the opportunities to come along. It's always been Interface's drive to influence and to try and make the right connections and get the collective willpower and collaboration required to get a project like this off the ground. And you know, when I say a thank you, I'm not just talking to yourselves out there for listening. We found that really to achieve, you know, our Mission Zero goals, to go further and achieve carbon negative goals, we really need to have real radical collaboration, and we really need a collective will to achieve those goals. And we found that we could not actually achieve that on our own. So we really discovered that we need to collaborate outside the industry. And I suppose in chronological order, if you actually looked at this process here to source an alternative for natural gas to get us on 100% renewable energy, it all started out with Sustainability Advantage, Rod Clare and Tarlock Guerin introducing us to Utilitas at the time. And then Fiona, who we worked with to develop a roadmap to identify the key stakeholders we would need to make this happen. It was fantastic. That was a great meeting, because it was her persistence and energy and enthusiasm that provided the moral support to keep focused and to get to the point we are at today. Our initial contact would have been with Sydney Water. Phil was there in Sydney Water. And I'm dropping names here because it's very important to understand that, you know, from an end user point of view, it is about relationships and connections and contacts and trying to get things to happen. And indeed, I would thank Arena, Dan Sturrock and Amy Philbrook, because they actually introduced us to Mike Davis at Jemena. At the time, I saw there was a hydrogen pilot plant set for commissioning or installation in Western Sydney. And from an interface point of view, we thought we want a part of that. And that's when Dan and Amy directed us to Mike. And of course, then the team in Jemena were very good. Initially, I think there was an apprehension about where we were coming from, but I think they certainly realized very, very soon that we were serious about our requirements and that we really did want to source a renewable gas. So Mike, Gabriel and Josh helped us to do that. And of course, you know, sourcing 100% renewable energy for our manufacturing facilities is key to achieving our Mission Zero and climate take-back goals. And we thought that the biomethane from the network was an elegant, low-cost solution. Obviously, there's a premium involved with the green attribute, but you know, it doesn't entail massive capital investment. In fact, none really at our facility at all. And as I said earlier, we really hope to be on renewable natural gas next year, Q3. I believe we might be the first actual manufacturer operating on 100% renewable in Australia by then. And again, to the point earlier about the methodologies around certification of this process, that is very important to us. And that's always been key in our discussions with Jemena and the key stakeholders within this supply chain. So it's very, very important that we have it certified so that on a global basis, Interface Australia can put up its hand and say, we're on 100% renewable energy, gas and electricity. And I think we will have that certainly before we come online at the end of next year. So I'm just going to leave it there. I'll probably rush it through because I am very conscious of the time of the day, and maybe just finish off there and leave it up open to questions.
Great, Aidan, thank you. That was fantastic. What a great story. You know, it's encouraging to see companies like yours take those steps and lead the way. You know, the fact that you've been looking at this for over 5 years is amazing. So I'm encouraged by the work that you guys are doing, and hats off to Ray Anderson with his vision way back in 1994. So really pleased to see what you guys are achieving. So we've got some questions on the chat line. I might start with those. I've got a couple of my own, but I'll start with those. And if you posted the question, if you could take yourself off mute, and I'll start with Mark's question here, and it's a question for Josh. So His question is, since raw energy is seldom the highest net resource value from precious limited bioresources, have you considered setting up a model that treats available biogas as a higher value processing byproduct rather than a key project focus? So I think I understand where Mark's coming from, but Mark, if you're on the line, I think I saw him drop off, so I'm not sure if he's still here, but if he's on the line, if you could jump on, that'd be great.
Well, I'll if he's not here, I'll jump into giving a bit of an answer. I mean, I definitely support that if there's other revenue streams that are available, then obviously that reduces the the price of gas that you need to achieve. Is there a background noise? I think, Jane, is there the background noise for others coming through? Yeah, thank you. So yeah, I think that it's great to have that opportunity. For us, we're looking at decarbonising our entire network, so it'd be great if those could contribute a lot. But I think where we're looking at now is what do we need for real scale, and I suppose our assumption is that it's energy focused large hubs, and it'd be great if those could then have other sources of revenue that could support them. But yeah, great. It'd be great to hear if there's other, at scale bio sources that could have other value streams to reduce the cost. Because basically, obviously, if you have those other revenue streams, then it reduces the costs for our customers like Aidan to decarbonise.
Great. No, thanks, Josh. And Joe or Aidan, did you have any comments regarding that question or any relevant experience from your projects?
Yeah. So from from an infrastructure perspective, generating gate fees will certainly help that, but at the same time, looking at securing offtake is easier than securing waste streams. So in terms of the reality of driving the gas price down because it's renewable, is probably quite difficult. And I think when you look at the price of hydrogen in comparison, you can see that's one of the drivers is the capital cost for that. So, I think where we've got sources of gas that can be tapped into, then it's just offsetting that capex. Then that can be driven by a unit price from an offtake perspective, as opposed to other facilities that require a full infrastructure to achieve that gas, basically.
Yeah, it's a complex piece, isn't it? With many different facets of project income. So, I think Mark's question touches on issues that we face as well around valuing digestate and how to add value to that organic waste stream that may not actually be waste. It may be a valuable source of product or carbon for an industry. So, Aidan, did you want to add to that?
Yeah, look, I think from our point of view, and everyone talks about circular economy and they talk about waste, and really a good business model doesn't rely on waste, because if you're producing waste, you want to reduce it. But there's just some waste that can't be reduced, and I think again, we have great access here with like the Malabar project, for instance. You've got a wastewater treatment process there, very consistent feedstock, supplied by the city. But down the road, what's going to happen? Will it decentralize? Are we going to look at sort of that disappearing and that becoming more sort of, as I said, dispersed around, where you have smaller treatment processes for different facilities, even within buildings, for instance. So there are certain risks going forward with it, but I think certainly you've got to start somewhere and go for the low-hanging fruit. And I think in our case, initially the cost of capital investment were very prohibitive. We had a good figure on the scoreboard there saying we were at 90% renewable energy globally for our manufacturing sites. That covered Australia then, and not having that, or China or Thailand. But nevertheless, we have an opportunity to do it now with not a very significant cost, although there will be an additional cost. And again, for us to actually meet those costs, it's really about getting efficiencies within our own processes and end users. So, two sides of it, circular economy. Waste reduction is what it's about. So you have to be very, very careful of building a model around that. I'm not sure if that makes sense.
No, thanks, Aidan. So I might just turn to Andre Lopez's question here, and Andre, I'm sorry if I pronounced your last name incorrectly. So it's a question for Aidan. Have you investigated syngas from biogenic sources as an alternative to biomethane? And this is a great question because this comes up a lot. And you know, for those who are in the industry, you'll know that producing biogas from organic waste is largely limited to feedstocks that don't include high lignin components, so woody, chaffy components, and in some cases, the only way to turn that into renewable gas is to gasify that and produce syngas. So, and there are lots of resources out there that are high in lignin and chaffy content. So, be interested in your thoughts on that, and whether you looked at syngas.
Absolutely, yeah. I would say probably about 10 years ago we were looking at it, and maybe that was when it was in its infancy. We weren't too impressed by the technologies available at the time, and also, you know, the material. At the time we felt it was quite a dirty process. I'm not sure where it's at now, but at that time then that's where we started to direct our attention more towards something that was contained, something that was already existing, producing the gas. You know, I said we looked at lots of options, and that's where we come in with sort of the Malabar, the Sydney Water, Jemena option. And I think that's about syngas. I wouldn't be knocking it about the future, because you might have noticed in my presentation that I talk about carbon negative products, and we use a lot of bio-based content in those. And that bio-based content can come from pyrolysis processes, as well as other areas. So it could be sometime in the future where we're actually running the gas off woody wastes, producing energy for the facility, and using the raw material to literally brush it onto the carpet, you know, make it into backing for the carpet. That's the concept. I mean, that sounds like a wide vision, but that's quite possible. But at this stage, no. But we did look at it at the time, as I say, and you know, we thought we'll move on. We didn't see too much in the way of good technologies at the time that were clean enough. Again, where we even put it on our facility was another question, you know.
Great, thanks, Andre. Thanks, Aidan. Andre, did that address your question?
Yes, it does. Thank you.
And certainly, I'd like to know where you're at now if you're actually in the syngas.
I mean, it would be interesting from you know, gas network perspective as well, because you know, the chaff and, you know, straw, etc., is, from what we've said, about 50 PJs of the biogas potential in New South Wales. So it's a significant amount. So if there are better ways to process it and get it into the network, then that works for us.
Yeah, great. Very good. Joe, anything further to add before we move on to the next one? You're on mute, Joe.
Yeah, I just realised 21st century, we should be used to this now, shouldn't we? Yeah, look, I think there's multiple feedstocks to generate different types of forms of energy, and it's about capturing that. I think there's a lot in the electrification space. I know I've mentioned it a few times with solar and wind, and I think where there's the opportunity for gas, I think we need to be decarbonising, offsetting fossil fuel, injecting into the grid, and having that circular economy. So yeah.
Great, thanks, Joe. This next question is from Peter Ralph, and Peter's asking the panel whether there's a role for algae to use digestate and scrub the CO2 from the biogas. So I think what Peter's saying is the algae biomass can be co-digested in the AD plant to provide some secondary benefits. So I'm not familiar with algae and how that can be used to scrub CO2. So if Peter, if you're on the line or available, great to hear more about your thoughts there.
Thanks, Mark. It's been really, really exciting. I've enjoyed the panel. And I just felt that in a lot of the presentations, it fitted into the value market of where the digestate was going. It was a cheap way of scrubbing the CO2 from the biogas. And yes, we've just spoken about the low calorific value of the AD, the algae can readjust the AD's calorific value, and to Aidan, it could be a byproduct back into your carpets. So I don't know. There's no massive supply of it, but I wanted to get that discussion or ask whether the panel had considered it. That's all.
Very good. Thanks, Peter. Aidan, sounds like you've been looking at all sorts of things.
We have indeed, and in fact, we actually were using carbon at one stage to extract pollutants from the ocean and algae and that, and then converting the algae into bio-oils, in fact. But that's a different process you're talking about, Peter. I'm wondering how you do that. Would you actually produce the gas first and then pass it to the algae? Because I presume it's a process of photosynthesis. So
Yes.
Yeah, okay. Yeah, look, that would be possible. And in fact, again, we're down the road looking at seaweed farming, producing materials to develop plastics. So you could see something like that. I think UTS might. I would actually contact UTS about that.
So I'm at UTS.
There you go. I know they're working on something around that. I'll be over. Peter, I'll talk to you.
Excellent.
Cheers.
Very good. Strategic question, Peter. Love it. That's great. Joe, you've worked in the UK. You've got a lot of experience in AD. Have you seen algae used for CO2 scrubbing?
We've actually explored it. It's the volume and the physical size dimensions to be able to remove the level of CO2 or clean the digestate effectively. Algae is a great product. It's got so many different uses that, everything from fuel to beauty creams and everything in between. There hasn't been, I think CSRO did quite a bit of work on algae. And the uses for algae and growing that. There hasn't been a commercial algae facility, and I think it's mainly due to the reason of size and input volume. We've explored utilizing the CO2 from scrubbing from biogas, blending with hydrogen to create natural gas again. So there's other forms and uses of CO2, and purifying that CO2 for further use, I think has another value stream, another revenue stream. So it should definitely not be discounted, and I think it should always be looked at. It's again comes back to the bankability of aligning everything to get it to work. Regional areas probably more success, just more space, lower cost of land. And potential capability, but it's just water, volume, liquid, input, everything that's required to get that out.
No, thank you. Thanks, Joe.
The facility was substantial enough. There's a great process, Mineral Carbonation International. I'm not sure if you're familiar with them. They can scrub CO2 out of flue gases to convert it into magnesium carbonate, calcium carbonate. And again, these are fillers that we can use in our processes as well. So that's a potential, but I'm not sure it's a question of scale. There's always the tyranny of scale, I think, is the biggest issue all the time, isn't it?
Great. Never a dull moment in bioenergy. You learn something new every day. So, so Josh, if you don't have anything further to add to algae,
I suppose the quick thing to add is that we're looking at the CO2 as a potential carrier for hydrogen. So through the methanation process. So I suppose it's just how those two options compare.
Yeah, no, I'm glad you raised that, Josh, and that's a great example of how the hydrogen industry and the biomethane industry can come together. CO2 is a waste product from the upgrading process, and when methanated with hydrogen, it can be a carrier for the pipelines and get hydrogen into homes. So I love that concept. So we'd love to see that developed further.
And I didn't detail it when I did the presentation, but a large part of that graph of our transition was methanation. So
no, that's great. Josh, you've got a question here from Peter Knight. Are there capacity constraints on the regional transmission network that would limit how much agri-waste sourced biomethane could be distributed to large industrial users? Great question, Peter. And I think for us as industry participants, access to pipelines is an ongoing issue. So, let's let's hear it from Josh. I guess this is the business you're in, so I'm sure you'd love to build new pipelines.
Yeah. Well, I think, I suppose in the ones that we've looked at, it's sort of reversing the flow in a way. So, out to some of the regional areas. So I doubt there'd be real capacity constraints at the transmission level, or where we're looking at anyway. But I mean, there are definitely constraints at the actual, once we come off the transmission network where our gas network operates. So that's there's some challenges, because obviously once you step up in size of project, you need to then get it up transmission pressures, which then creates creates additional cost for those projects. So that's probably where we're looking at the challenges. So going from a smaller project that can service a local area to a larger one that might need to step up to transmission pressures, and how that might actually work. I don't think, well, I haven't looked at whether we'd be limited by any transmission capacity. I'd love if we started to come against that challenge. That would mean that we'd be at massive scale.
Good problem to have. Yeah. Well, it'd be great if pipeline valves work like transformers, and you could flow electrons in the opposite way. So, Joe, you've got a number of regional-based projects. How are you seeing the availability of infrastructure to inject natural gas from the perspective of your opportunities?
Probably slightly different. I think we explored it in one of the regional facilities in Victoria. I think we was about 4 or 5 Ks from the network, and the cost for that was about $5 million, or $4 to $5 million. So, quite a large cost for connecting into that network that throws into the economics of the facility again. So, regional, it's about aligning. A lot of the work that we've done with AGIG has been to look at where are the sort of the black spots in the grid. Can we, where's the grid connections? Let's focus our design around meeting those requirements, as opposed to highlighting we've got a site location here, and we're going to build a site even though it's 10, 15, 20, 50 kilometers from where the local gas network is. So I think it's about working to the site location, the understanding of the layout of the land, and where's best to connect into that point. I think the other thing that we found is connecting into transmission from a pressure perspective and a cost perspective is obviously a lot greater than connecting into the distribution node. When you're in the distribution node, it's a lower pressure, it's easier to connect. You can use the pipe as a bit of storage. There's a way to manage that. But at the same time, you've got seasonality issues around when that gas is being consumed. So you can't sometimes give a flat line gas flow into that like you would if it was a transmission line. So there's pros and cons between each connection, each node, what the pressure is. Pressure can account for a lot of operational costs. Getting that gas pressure up to a higher pressure to go into a transmission line can sometimes be the tipping point of whether the project's viable or not, just from a cost, from a power cost, carbon cost.
No, thank you. And Peter, are you happy with those responses, or any further clarification needed?
No, that's great. Thanks very much. Appreciate the insight.
Thanks, Peter. Well, it looks like we've come to the end of our allocated session. Can I say a huge thanks to the speakers for this last session? Hugely insightful, as always. So really appreciate the time and effort and energy that you put into your presentations. This is a great sector to be involved. So I'm certainly enjoying working alongside you as industry partners in developing this biomethane industry. A big shout out to Bioenergy Australia for pulling this together. Thank you, Shahana. I think Shahana's left. Georgie and Lauren for organising today's session. I know it's moved a few times, and you've done a great job facilitating the speakers and bringing the audience together. So very much appreciated.